Hey guys, welcome back. So go ahead and pause the video so you can set up or print your outline, and then come back and join us when you're ready. Alrighty, so today we are moving on from equations and moving into solving inequalities. Okay, very similar, similar solving process. However, inequalities have much larger solution sets, and we're going to talk about that. So in inequality, this is a statement that compares two expressions that are not equal, again, because we're not solving an equation anymore, so we are comparing two expressions that are not equal by using an inequality sign. Equations have either one solution, infinitely many solutions, the ones that we can plug in anything, or no solutions. So one, all of them, or nothing. Inequalities have sets of solutions. So let's look at our directions. It says solve each inequality. So we're going to solve. Graph using a number line. We're going to graph. And then we're going to write the solution in interval notation. Now, up until this point, you have probably solved some simple inequalities. You have probably even graphed using a number line. Interval notation, it's going to look a little bit new. So let's look at our first example. 3m plus 4 is greater than or equal to 16. So I want you to look at this. Look, I'm even going to draw my line, just like I'm solving an equation. How are we going to isolate m? First, is there any distributing to do? I don't see any parentheses, so I don't think so. Next, are there any like terms? So on the left side, do I have any like terms? Got a 3m and a positive 4. I think we're good. All right, now we're going to go ahead and isolate m. So I have 3m, or 3 what? Times m plus 4. Okay, so I have a multiplication and an addition operation that I need to undo. So PEMDAS in reverse, let's undo this addition. So plus 4, we are going to go ahead and subtract 4 from both sides. So I have 3m is greater than or equal to 16 minus 4, 12. Awesome. Anything different so far? Nope, we're following the same exact process. So 3m, or again 3 times m, so isolate that m. If we divide both sides by 3, we get m is greater than or equal to 12 divided by 3, 4. Okay. M is greater than or equal to 4. Now remember, we did see equals before. Nope, no longer an equation and an inequality. So let's see what this looks like on a number line. So if I set up a number line, and you can set it up kind of however you want, but what I'm going to do is, I know I'm starting at 4, so I'm going to go ahead and put 4 in the middle, a couple numbers below, a couple numbers above, 6, 2, awesome. It doesn't have to be perfect, okay? We're just setting up what it's going to look like. So, at 4, m is greater than or equal to 4. What I want you to think about, is 4 included in our set? Does 4 work? If I go to plug in 4, what's 3 times 4? 12. 12 plus 4 is 16. Is 16 greater than or equal to 16? Well, it's equal, isn't it? So that means it's included in our set. So if it's included, you need to shade in your bubble. And that is all because it is equal to. So from the 4, in our solution set, 4 is included, yes. Are numbers above 4 or below 4 included? So m is greater than, so where are the numbers greater than 4? Above it. So I'm going to shade above. So this is where the big difference between equations and inequalities come into play. Inequalities, you've got a solution set. Any number. That's why I shade all of this. 4.000001. That's even a solution because it is something bigger than or equal to 4. So we really have an infinite number of solutions, but it's just the stuff 4 or greater. So inequalities have a large solution set where equations tend to have one, sometimes none, or sometimes it is infinity if we get one of those special ones. So this is probably a little bit of a review, but now let's look into interval notation. So over here in my left-hand column, you're going to see when we have a greater than or equal to or less than or equal to, we identify that using brackets. If it's a less than or a greater than, that's parentheses. So brackets represent when a set is closed. So that's when we have that shaded bubble. And then less than or greater than, those parentheses, those represent when something is open. And by open, I mean that open circle. So if we write what the solution set of m is greater than or equal to 4 in interval notation, it's also called set notation, what we're going to do is, well, look at our solution. If I look at my number line left to right, beep, 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 where do I stop? I stop at, well, I technically start at 4, and then where do I stop? Well, I keep going. So what does that mean when we keep going? So we start at 4 and we keep going to where? Forever. What's forever? Infinity. Ooh, that is not pretty. Let me do that again. So 4 to infinity. So again, let's look back. This is a closed, so I need to use a bracket, which means 4 is included in my solution set, and then I go to infinity. Now, does infinity have any like true ending point? Well, it just keeps going and going and going and going. So since it's open, since it continues going on and on, infinity will always use a parenthesis because that represents it's open. It doesn't have a true stopping point. Okay, so that's interval notation. All three of these answers are my answers. I have it written as an inequality, so it's kind of written algebraically. I have it shown graphically using a number line, and then we have it in interval notation. Ready to try another one? Okay, let's look at 2 times the quantity v minus 1 is less than 4. Just like solving an equation, where do we start? All right, so I have 2 times the quantity v minus 1. So let's go ahead and distribute that 2. 2 times v, 2v. 2 times negative 1, always include that sign. Negative 2 is less than 4. Alrighty. Again, if you want, you can put that line down to keep you organized. I don't see any like terms on the left side, so now we're just going to isolate v, get v by itself. So I'm going to undo any addition and subtraction. So that's going to have, I'm going to add my 2 to both sides. So I'm left with 2v is less than, I always remember this one's less than because it kind of looks like a squished L. So less than 6. 2v, what's the operation here? 2 what? 2 times v. So we're going to divide both sides by 2. Because 2 divided by 2 just leaves us with 1. So v is less than 3. Cool. So let's go ahead and set up our other number line. So again, I'm starting at 3. So I kind of do this shorthand a little bit. Start at 3. Couple numbers above. Couple numbers below. So at 3. Is 3 included in our solution set? Is it open or closed? Well, it is everything less than 3. Does that mean 3? Well, if I plug this in, 3 minus 2 is 2. 2 times 2 is 4. Is 4 less than 4? No, it's not. So 3 is not included. So we designate that with an open circle. And it says less than, so we are going to shade everything less than 3. Cool beans? So let's try one. I like to, if 0 is ever in my set, I always try that because that's easy peasy. So 0 minus 1 is negative 1. 2 times negative 1 is negative 2. Is negative 2 less than 4? Heck yeah, it is. So that works. So I have algebraically written. I have it graphed on a number line. Now let's try the interval notation again. So reading your number line, left to right, smallest to least, what is our smallest solution? So what does that arrow represent again? It just keeps going. Going where? To infinity. However, which infinity? Which direction is it going? It's going in the negative direction. So the smallest in our set is actually negative infinity because it's going in the negative direction forever. Does that make sense? So we're heading to negative infinity. So if we come to the right, coming, where do we stop? So from negative infinity to 3, those are my solutions. Now, negative infinity, open or closed? Infinity, it's always open because it goes on and on forever. That 3, was our 3 open or closed? Was it included? Nope, 3 did not make the statement true, so it's not included, and we show that by parentheses. All right, hopefully that's okay. You guys let me know if you have any questions. Okay. So far, nothing really has changed between how we solve an equation and how we solve an inequality. However, there is something different when we have some negatives, and it's specific to multiplying and dividing by negatives. So let's go ahead and try this one. 5y plus 2 times the quantity 3 minus 4y is less than 330. Oh, could I have picked a bigger number? It's all right. We'll survive. So, process. What do we start with? Is there anything to distribute? Yes, there is a beautiful positive 2 out front, so let's go ahead and distribute that. So, positive 2 times 3, positive 6. Positive 2 times negative 4y, negative 8y. All right. So, I've still got a 5y I need to bring down. There's a lot going on here, so I want to make my line less than 330. Okay. Commutative property. Can we combine any like terms? Show 5y and negative 8y. So we've got negative 3y plus 6 is less than 330. Cool beans? So we've only got one variable. That's nice. Only variable on the left. So let's move everything over. So let's undo this plus or positive 6. So let's go ahead and subtract 6 from both sides. So negative 3y is less than 330 minus 6. So 224. Sweet. All right. Now, we are going to divide both sides and to get rid of this negative 3. So we're going to divide both sides by negative 3. So y is, I'm going to leave this blank for a minute because I'm going to show you something. So 224 divided by negative 3, so that is going to give us a negative 70. Does that not divide evenly? No, it doesn't. Let me look back and check my math. Alright, I distributed my 2. All that's good. Brought down, combine, negative 3y, good. 330 minus 6 is not 224. It is 324. Let's see if that divides a little easier. Oh, it definitely does. 3 goes to 3. 108, thank you. Negative. Alright. Now, when multiplying or dividing by a negative, so what about those pesky negatives? When multiplying or dividing by a negative, we must flip the sign. I'm going to make myself a thought bubble. When multiplying or dividing by a negative. Okay, we must flip the sign. So whenever I remember to flip the sign, I always circle it or highlight something like, yes, you did that, you solved it correctly. Okay, let's take a little sidebar because I want to explain why we do that. Okay, so let's say And there's a video over here. This guy, I'm going to do a quick explanation, so he'll explain really well, like, why we do that. So if it doesn't make sense to you, go ahead and watch that. It's a short little 3-minute video. Okay, let's see. Let's do something simple like 4 is greater than 0. Does everybody agree with that? Okay. Does everybody agree with that? Hopefully, yes. So let's say we make this -4. So let's say it said -4 is equal to 0. So if we divided each side by a -1, we would get -4 is greater than 0. Is that a true statement? No. So the only way when we're dividing by a negative, same thing would apply with multiplying, is to flip the sign. Is -4 less than 0? Yes. So when multiplying or dividing by a negative, you have to flip the sign, because essentially what it's doing is you're making something that was once larger. When you're dividing by a negative, yeah, you're not only making it smaller, but you're making it a negative number. Okay, so when you're dividing something by a negative, you've got to flip the sign. That's just a simple example. So again, if you watch him, he goes through a nice explanation of why we do that. All right, so let's go ahead and continue practicing with our number line and our interval notation. So number line, -108. That's where I start. So a couple smaller, -110. A couple larger, -106. Alrighty, so at -108, is it open or closed? Open, because it is not equal to, it is not included. And I remember to flip my sign, so everything larger than -108 is to the right. So in interval notation, who is the smallest number in our set? So looking from left to right, who's the smallest? -108. And it goes from -108 all the way up to infinity. So now the hard part, open or closed. So -108, open or closed? It was an open circle, not included, and infinity is always open. So we close it using 2 parentheses. All right, there was a lot going on with that problem. So let's try another one. -5, 6b. Ooh, this looks ugly. -5, 6b is less than or equal to -3/4. Okay, so -5, 6b, or -5, 6 times b is less than or equal to -3/4. Cool beans. So when I look at this, I would think, okay, times, so I want to do the inverse operation and divide. So if we're dividing both sides by -5, 6, that's one option. But when dividing fractions, that gets kind of yucky. So instead of dividing, I can multiply by what? Multiply by the reciprocal. So I'm going to multiply by -6/5, and I can watch my 6's cancel and my 5's cancel. Beautiful. So b is, wait a minute, what did we just multiply by? A negative. So you better remember to flip that sign and do it to the other side. -6/5. Can I simplify anything? I don't think so. So -3, just going to multiply straight across. -3 times -6, 18. Oh wait, I could have simplified 4 and 6. 2 goes into both. 2 goes into 4 2 times. 2 goes into 6 3 times. So -3 times -3 gives me 9, and 2 times 5, 10ths. It wouldn't have mattered if you didn't simplify. You would just need to simplify your fraction once you have the answer. All right. So b is greater than or equal to 9/10. Awesome. Let's put that on a number line. To move him over. So 9/10 is between 10/10, or 1, and 8/10. So at 9/10, is it open or closed? So look at your inequality sign, greater than or what? Equal to. So it is allowed to be 9/10. That would make it true. And all the items that are greater than. So shade everything above. Cool. So when we are writing in interval notation, our smallest, so left to right, our smallest solution is 9/10. And our largest solution, all the way up to infinity. So 9/10, is it open or closed? So equal to told us it's closed, so I use that bracket. And infinity is always open, so we always use a parenthesis. So solving an inequality, identical to solving an equation. However, if you divide or multiply by a negative, you've got to remember to flip your sign, or else you're going to have the opposite solution set that you need. Alrighty, so let's look at the fairy tale spectacular. So the fairy tale spectacular is coming to town. Woohoo! So admission to the fair costs $12. Each ride costs 50 cents. You have $25 to spend at the fairy tale spectacular, including admission. So it first wants us to write an inequality that represents this situation. So what's our important info? Well, we got to pay to get in. So first, we have our admission is $12. So we start off $12 right there. I already spent it just by walking through the gates. All right, now what else do we have? Each ride costs 50 cents. Okay, so we're already spending $12. What else are we going to spend? 50 cents. Okay, am I just spending 50 cents one time? 2 times? Who knows how many times? So how do I represent that? Each what? Each ride. So that each tells me I am going to multiply, because it's 50% or 50 cents, excuse me, per ride. All right, and we have $25 to spend. So equals 25. Sound good? Go back to the question. What are we supposed to be writing? We are supposed to be writing an inequality. Do we have to spend all $25? No. Can we spend more than 25? Not unless you're borrowing money from mommy. All we got is 25 bucks. So we have $25. Can we spend all 25? Sure, why not? So that would make it an equal to sign. But again, can we spend more than 25? We don't have more than 25. So we can spend less than or equal to $25. Sweet. How's that for your inequality? All right, I think there was something else. It says solve the inequality to determine the maximum number. Ooh, I like this. Maximum number of rides we can enjoy at Fairy Tale Spectacular. So, if we want to find the maximum number of rides, who are we solving for? We're solving for R. So to solve for R, go ahead and simplify. So we have 12 plus, so we have an addition, and 50 cents per ride. So times R. So we need to undo a positive 12. How do we move positive 12? Go ahead and subtract it. So 50 cents per ride is less than or equal to 13 bucks. Is that how much we have left over? All right. So simple division. How many 50 cents are there in $13? So R equals, oh, sorry, R is not equal. R is less than or equal to what? 26. So what's the maximum number of rides? 26 rides. Awesome. So when you're looking at your word problems, always think about, can you spend that much? Or are we allowed to buy that many? Or can we have that many? Whatever. So can it be equal to? And then from there, you're just thinking, can we have more or less? All right. Hope you guys have a great day.